All right. So one thing we often want to do when we're using vectors is we want to talk about unit vectors. Now in general, a unit means one. So a unit vector is really any vector that has magnitude 1. We're going to talk specifically about two unit vectors known as I hat and j hat. Okay, so I, the vector I, and we usually call it I hat, that signifies that it's a unit vector. And I hat equals 1, 0. So I hat is kind of the horizontal unit vector, meaning it's the vector that's just horizontal and it has magnitude 1. And then we also have j hat. Okay, so j hat is a vector, and like I hat, it's just going to be a real simple vector. It's the unit vertical vector. So it's vertical and it has length 1. Okay, now here's the cool thing about I hat and j hat. I can take any other vector in two-dimensional space and I can rewrite that vector as a combination of I hat and j hat. Well, what do you mean? Well, let's take a general vector. Let's say the vector 2, 3. Now I know that 2, 3 means the vector that I go horizontally 2 units and vertically 3 units, 1, 2, 3. Okay, so here is this vector, we're going to call it A. So here is vector A. Okay. But I could think of vector A as a combination, called a linear combination, of I hat and j hat. Now, do not overthink this. Okay, what do I mean by that? Well, I is our unit horizontal vector. So how many i's do I need if I went over 1, 2 units horizontally? Well, I need 2 i's. So this would represent 2 I hat. And how many j hats, vertical unit vectors, would I need if I went 3 units vertically? 1, 2, 3. I would need 3 j hats. Now notice I've got 2 I hats and 3 j hats. If I add those together, I get my A. Vector addition, tip to tail, that would give me my A. In other words, I can write A as, we call this a linear combination. It's not something we really need to know now, but if you're going to go on to anything like linear algebra, you'll eventually need that terminology. Big picture, I can write A as a combination of 2 i's, 2 I hats, plus 3 j hats. Okay. Now, what does that mean? Well, let's just kind of make sure that really makes sense. Our picture shows that it makes sense. Let's just do that with the numbers. That says 2 times our I hat, which is 1, 0, plus 3 times our j hat, which is 0, 1. Okay. Now, when I do scalar multiplication, right, that means I just kind of distribute the scalar to each term. So this becomes 2 times 1, which is 2, 2 times 0, which is 0, plus distributing that 3 times 0 is 0, 3 times 1 is 3. And then if I do my vector addition component-wise, meaning I'm going to add horizontal components and add vertical components, 2 plus 0 is 2, and 0 plus 3 is 3. So notice that gets me right back where we started, to 2, 3. Okay? Any vector in two-dimensional space can be written as linear combinations or multiples of I hat added to multiples of j hat. Okay? Let's look at one more example. Let's say we want to write the vector negative 1/2, 3/4 in terms of I hat and j hat. Okay? Well, in order to go negative 1/2, I need to change my horizontal unit. I need to change that from a 1 to a negative 1/2. Well, I can do that by taking that times negative 1/2. So when I take my I hat times negative 1/2, I get negative 1/2, 0. Okay? And then for my vertical component, I need to change this 1 to a 3/4. Well, I can do that by multiplying by 3/4. 0. So this becomes 0, 3/4. And notice when I add those vectors together, negative 1/2 plus 0 is negative 1/2. 0 plus 3/4 is 3/4. Okay? So that tells me that if I add negative 1/2 I hat, so this is negative 1/2 I hat, plus 3/4 j hat, that's going to give me this vector negative 1/2 3/4. Okay? If you're thinking, is it really that easy that I take I hat times the horizontal component and j hat times the vertical component and add them together? The answer is yes, it really is that easy, okay? I hat and j hat are not going to be super important for us right now, but again, if you're going on to something else like linear algebra, or if you're going to end up doing the entire calc sequence, these come up a lot in, say, Calc 3, in linear algebra. They come up a lot in computer programming, things like that, okay?